Which question can you tell me?
I
Yeah,
am
ma'am.
11.
11. Okay, 1 second. Okay, can you see my screen?
Yes, ma'am.
Yes, ma'am.
Yeah, okay. 1 second. Question 11, right? Um, this flowchart one.
Yes.
Yeah, what's the doubt?
Ma'am, I don't understand how to solve.
Okay, so I think I discussed this once last week also, but okay, let me give an example quickly, okay?
Okay.
So flowchart questions, how do we solve? First of all, best way to solve is take some numerical values as your example, okay, as a test case. So there are three variables here, right? A, B, C. See what the question is saying is you have to interpret the flowchart and answer the following question. A, B, C are three distinct integers. That means none of them can be a copy of the other, right? And what will X
Yes.
represent at the end? So just take A, B, C as any three random values. You can take them as like 2, 4, 5, anything you want. Okay. So let's say A is 2. 1 second. So A is 2, let's say. B is 4 and C is 7. Okay, I can take this. So first you will go to the terminal, that is start. Then we come here. So is A greater than B? So you check in your example. Is 2 greater than 4? No, right? So we will go this way.
Yes.
So next comparison, this decision box is asking, is C greater than B? So 7 is greater than 4? Yes. So you'll
Yes.
go this
Yes.
way. So X is now assigned the value of B, right? That is 4.
Ma'am, please one again
Yes.
repeat.
See, first we started here. First comparison, first decision box is asking, is A greater than B? So in our example, is 2 greater than 4? No. So we go this way, right? Then you come to this decision box. This is asking, is C greater than B? That is 7 greater than 4 or not? So 7 is greater. So you come here. And now B's value is assigned to the variable X, right? And after this, you can
Yes.
just end the procedure. Okay. So if I take one more example, let's say A is 7, B is 9, C is 6. Let's say 8. Okay. Again, do the same thing. Is A greater than B? 7 greater than 9? Yes or no?
No, ma'am.
So
No,
again,
ma'am.
this way only we are going.
N-
Now
No.
next question, C greater than B? Is 8 greater than 9?
No.
So
No,
now
ma'am.
you go this direction. So this decision
Yes.
box next. Is C less than A? So
No.
8 is less than 7, right? So you come here and assign A's value to X. So both of these examples, what did we see? At the end of execution, X is storing which one? The middle value, right? Not the greatest, not the least, the middle one. So first
Ma'am,
example, we
here,
got B.
Not
Yeah.
less than A.
ma'am, here C is not less than A, na?
Yes, ma'am.
Sorry to interrupt, but
C. Okay.
we will
Sorry.
follow.
This example is saying C is not less than A. So we'll go this way, right? X is assigned C. So in this example, we got C as X's final value. So both of these examples, you see, X at the end of execution is storing the middle value. Here it is storing 4. Here it is storing 8. So what are your options? Largest number among ABC, smallest among ABC, mean of ABC, or second largest among ABC? So which one? Middle number means second largest, right?
Yeah.
Second number.
among
2
8.
is smallest, 7 is largest, 4 is second largest.
Mean,
Again, here 9
mean
is
value.
largest, 8 is second largest. So this is the answer. D is the answer. It is not mean. Okay. Mean of this is what? It is saying mean of, if you say mean of A, B, and C, then mean of 7, 9, and 8 is what? 7, 8, 15, and 9, 24. So 24 by 3 is 8. So that is also correct in this example. Now do this one. 2 plus 4 is what? 6. 6 plus 7 is 13. So 13 by 3 is point something, right? So it is basically the second
Ma'am,
largest value.
please mute everyone.
Sorry.
सारी बोतलें ले जाओ उधर रख दो ये तीन जो खाली हुई हैं
Other people, please mute yourself if you don't have a question. Okay.
Hello, ma'am. Hello.
Yeah.
Ma'am, I have a doubt in practice 3 assignment.
Yeah.
Please
One second. Just I'll
what the
take all the
question?
doubts. Just let me finish this question. So is this clear? Any question here?
Yes, ma'am. Clear.
Clear, right? Okay. Next question is what?
Ma'am, I have a doubt in practice 3 assignment.
Week 3 practice?
Yes, ma'am.
Week 3 we haven't discussed yet. So let's first take the doubts from weeks 1 and 2. Okay. Then I'll take week 3.
Okay.
Ma'am, hello.
Yeah.
Ma'am, I have
In
doubt.
this session, you will take the doubt.
See, in this session, I will, after taking these 1-2 week doubt, I will complete week 3 theory. Then I'll take any doubt if you have from week 3, if anyone has completed.
Yes. After the theory, you take.
Yeah.
Hello, ma'am. Hello?
Yes. Yes.
Ma'am, I have a doubt in activity question 2.6.
Okay. Activity, right? Okay. Let me share that. 1 second. Can you repeat activity 2.?
2.5 and 2.6. I thought you go to 2.5.
Okay. 2.5.
Oh, no. That's what 2.5.
Yeah. Just a second.
2.4. You go to 2.4 and 2.6.
2.4. Okay. Yeah. Which question in 2.4?
Second question. I think the answer should be 0, but they
Okay.
accept
Let's
the
see.
answer
Let's see.
30 as a correct answer.
Yeah, let's see what it is saying. So assume that we have already figured out the maximum number of bills generated by any shop. Okay. So this is based on shopping bills data set. So whatever shops are there, they're saying that we know the maximum number of bills generated by any of those shops. So it is stored in a variable called max. Now we have a new pile containing 30 cards. All cards in this pile are bills from 3 new shops. Okay, these are not the shops that we have in our data set. So what is the least number of cards that we would have to iterate over to determine the maximum number of bills generated among all 6 shops, right? So since we already have the data that from the previous 30 cards or whatever cards we had from our data set, what are the maximum number of bills from each shop? That data we already have. Now we have 30 new cards. So our goal is what? We want to find what is the least number of cards that we have to iterate over to determine maximum number of bills generated among all 6 shops. Now, among all these 6 shops, it is possible that from the previous 3 shops, it could be one of the shops that still has the maximum number of bills generated, right?
Yes, ma'am.
Or it could be that from the 3 new shops that we are now having this 30 cards from any of these also, one of the shops might be having the maximum number of bills. So you have to go through all 30 new cards. Right?
Yes, absolutely.
Clear?
Oh, that's why we have already finished one pile of cards of 30 cards.
Yes.
That's
See,
why
this
we
new
can
pile of 30 cards is new pile. Okay, this was not there before.
So we can initialize from the second pile as the 30 as the minimum count.
Right. So next time when we start iterating over these 30 cards, now we are generating the data for 6 shops. Okay. It might be that any of the previous 3 shops data is also present in this 30 card file. So that is also possible, but it is also possible that maybe some shop here in this new 3 shops has say 15 bins. So that could be the highest. So you have to go through all 30. Okay. But not the previous 30, since that max is already stored.
Okay, ma'am.
Yeah. Any other question from 2.4?
2.4? No, till now, no question from 2.4.
0.5 or 6, anything from
2.
activity?
2.6.
2.7.
Okay, we'll go one by one. Okay. 2.6, which one? Which question?
Which question? Question number 2. I
Question 2.
think that the count should be exactly 6 times, but the answer is told us that at most 6 times.
Let me see. Okay. So consider a new version of the paragraph words dataset. Everyone knows the words dataset, right? So every
Yes.
card here has one word written on it. And what other information do we have? The part of speech, the letter count, these things. So assume that we have figured out the counts of all unique words in this dataset in one iteration. So what data do we have? That we know all the letter counts. We have figured out the counts of all unique words. So how many times each word is occurring? I know that. Okay. Now after this, we initialize a variable called max and set it to 0. This is used to find the count of the most frequently occurring word. So this is actually a very widely used problem here in our course. This most frequently occurring word. So that's the goal to find out this. We now perform a second iteration over the unique words in any order to compute the value of max. Okay. So final value of max is 6. They're saying how many times was it updated during the course of the program? Okay. So what data do we have? We know the initial number of occurrence of every unique word, and this is used to find most frequently occurring word. Second iteration over unique words in any order to compute the value of max. Okay, so basically max should contain whatever is the maximum number of like occurrence, right? Like which unique word is occurring the maximum number of times. So if final value of max is 6 means what? Just tell me this one. What does it mean if max is 6?
How many time it was updated? It is asking.
Max is 6 means that the unique word that has
Unique word has letter
appeared the
count
highest number of
6.
times. Okay, that is 6.
Hmm.
So maybe there is some word the. This word has appeared 6 times. No other word has appeared as many times. So max is that. So how many times was it updated?
So
At
if I
most
start
6 times.
initialize from 0, then we have to update from step by step that if any word comes 2 times, then we can
So
uh,
every time the word comes, we have
implement it
to do that,
quickly.
right?
No, ma'am, it is asking the unique
No,
word.
I'm not
Count
asking.
of
I'm not
unique.
saying that. I'm saying that first time we did the iteration. Okay, first iteration. That time, how many times this was updated?
First time when one
That
unique word
count.
found, then one. If two unique
Could
words
we have
found,
updated
then
5
two.
times?
No, ma'am, at most 6 times, I think actually.
See, first look at the question. What it is saying? Assume that we have figured out the counts of all unique words in one iteration. Right. That means every time, that means in that one iteration, every time that word, let's say the is the word, every time that word came, we updated the value of some count variable, right? And then we got this 6. But now the question is, now we have the counts for all such words. And now we are doing one iteration over this unique counts to find the value of max. So how many times is this now? In the second iteration, how many times do you have to update it? This is the question.
Ma'am, at
So,
most 6 times, I think.
so why at most 6? Why not exactly 6?
Because, ma'am, the unique word appearing one by one. If one unique word was found, then max was 1. If two unique word was found, then max was 2. And last day, step by step, there was max as 3 unique word was found. Then at
Look.
most we update only 6 times, not more than 6 or less than 6.
Right. That is correct. So if I break it down, let's say there are 6 different unique words. Okay. After the first iteration, we saw that that C1 is the count of the first unique word, that is 1. C2 is the count of second unique word, that is 2. C3 is 3. C4 is 4. C5 is 5. And C6 is 6. These are counts of unique words. Okay. After the first iteration that we got. Now we have to iterate among these values to find what is the max one. Okay. So what can happen? This max variable is first set to 0. Okay. Now in the first iteration, I pick this C1 count and I see that it is 1. Right. So max is now updated to 1. Since 1 is greater than 0, every time we find a higher value, we will update max. This much is clear? Right.
Yes, ma'am.
Second, I found in that iteration, going for the next value, we have C2. So C2 is again 2, which is greater than 1. So again, max is updated. So now max has been updated how many times? Twice. Like this, how many times will max be updated? Till I reach 6. Now this 6, it is here I have taken this data that C6 is the last one. Let's just change it a bit. Let's say C4 has count 6, C6 has count 4. Okay. So once I reach C3, then I see 3. Max is 2. So max is again updated now to 3. Next I go to C4. C4 is 6, which is greater than max. So max is now updated to 6. After this, when I go to C5 and C6, any of these values, are they greater than max? 5 or 4, are they greater than max?
No, ma'am. 5 and 4.
So that means max is not updated again. So how many times was max updated? 4 times only. So what is the maximum number of times max can be updated? 6 number of times, or
6 number of
however many
times.
counts are there of
Hmm.
unique words, right?
Mhm.
That's why it is not exactly equal to. It can be less, but it cannot be more.
Okay. If there is a MSQ question, then we can take the less than 6 time and at
See,
most
the
6 time
answer will
also.
remain same. No, exactly 6 will not be the answer. Okay, you cannot say less than 6. You cannot say more than 6. More than 6, so definitely you cannot say. But less than 6, you cannot say. Why? Because not every time it will be less than 6. No, it can be that it's done exactly 6 times. That updating, it has done exactly 6 times. It has updated the value of max. So you cannot say for sure whether it will be less or exactly. All you know is it can be at most 6. That means it can be any value from 0 to 6. It can be that the first word count that you found was 6. So in that case, max was updated only once, right? For these other 5 values, you don't have to update max. That can
Yeah.
also be the case. Okay.
If we
So all,
have to end.
so all you can say for sure is that at most 6.
Okay, ma'am.
Any other question from 2.6?
Ma'am, in 2.2, second question, ma'am.
2.7, ma'am.
Okay, I'll take 2.7 right after this. Okay, 2.2, let's see. This one. Okay. Maximum marks, procedure to find maximum marks. Okay. So at any intermediate stage in the procedure's execution, everyone knows what is the max procedure, right? How to calculate maximum marks. So what does the variable max store? At any intermediate stage, what does max store? Choose only the option that
Ma'am, one
applies for.
second. Ma'am, I have a different question regarding the flow chart. Sorry, the found
2.2
is
only has 2
equals to
questions.
false.
Flowchart question is 2.1, not in 2.2. I
Flowchart
think
was in
you.
2.1.
I think she is making mistakes, ma'am.
Can
Let's
I
check
show it,
2.1.
ma'am?
I'll show you 2.1. See if there is any question here.
In this one
one?
question, ma'am.
Yeah,
Yes,
okay.
ma'am.
See,
The
this is
second
saying
question, I guess.
this one, right?
Yes, ma'am.
See, what is the flowchart doing? Use the following flowchart that was used at the end of lecture to answer the remaining questions. Okay. So at first found is set to false. Then it is coming to a decision box and it is checking another card and not of found. So not of found will be true when? When found is false, right? Not of false is true.
Yes, ma'am.
So
Yes,
both
ma'am.
of these conditions have to be true, right? That means another
Yes,
card is
ma'am.
there and found is false. So if both of
Yes,
these
ma'am.
are true, then you come here and then you check if it is the correct card. If yes, then found is set to true. So the
Okay.
question is asking what after a certain number of steps in the iteration, the flow transfers to the no branch. Right. So which of the following situations are possible at this stage of the program's execution? Okay. So no branch, when will we go?
When we have no cards and when we have the found one of the card, like found is equals to true.
So if found is equals to true, then there is one
We
more
go
arrow
for the
here.
no branch.
Yeah.
Huh.
So first option is the variable found stores the value true and some cards have not been read. So this is one of the possibilities that found is storing true, but there are still some cards there, which I haven't gone through yet. Right. So
Hmm.
in that case, I will come to this branch, this correct card, and then this no comes from found equals to true, this arrow no that comes here. And then you again go back to the first decision box. So this is one possibility.
Then, ma'am, here not found will become into false, right? Like after found is equals to
Yes.
true,
If found
we
is
go
true,
back
then not
to the
found, will be again false.
false. So
So
then
once
will,
that
if it is
happens,
false,
yes,
mm-hmm.
once that happens, found cannot be set to false again, right? Once found is set to true, it cannot be set to false again.
Okay.
That is one possibility. Another, this one, the variable found stores the value false and some cards have not been read. That's not true. If found is set to false, that means this will
Hmm.
be true, right? So you're not going to the
Okay.
branch.
Okay.
Then third option is variable found stores the value false and all cards have been read. This is obvious. If all cards have
Huh.
been read and
That one.
found is false.
Last two I got, last two options I got it, but I was having confusion when first two options.
Do you understand now why this is happening?
Yeah, now I got it. Thank
Okay.
you, ma'am.
So 2.7, right? 2.7.
Ma'am,
Which, yeah. Yeah, who was asking 2.7? Which question?
Number 1 and 2.
1 and 2. Okay, let max marks be a variable that keeps track of the maximum total marks. Okay, in the scores data set. So you know that every card has some total mark value, which is the sum of physics, chemistry, math, right?
Yes.
So it keeps track of the maximum total marks. That is whatever is the maximum total mark gotten by any student. So let max card be a variable that tracks the index of the card, which has the maximum total mark. Every card has some index associated with it, right? Index starts from, I think, 0, right? Card index, sequence number. Can anyone check the data set? I think it starts from 0.
Ma'am, it start from 0.
Right.
Yes, ma'am.
So this max card variable is storing what? Max marks is storing the maximum total marks. Max card is storing the sequence number or the index of that card. Okay. We write a procedure similar to the one given in lecture to determine the maximum total marks and the index of the card corresponding to it. So it is asking if max marks is updated n times during the execution. That means we have found n such opportunities to update max marks. That means n people we have gone through, right, who have scored greater than the last one. So how many times is the variable max card updated?
Anytime.
So this is a very important data given at the end. Assume that no two cards have same total marks. So let's say I have 5 students. Okay. All of them have scored 5 different total marks. Now let's say the 5th student that I come in my iteration, the 5th card, that student has scored the highest total marks, let's say. And at this point, I see that 5 times that max has been updated. The data is in such a way. Let's say 10, 20, 30, 40, 50. These are the total marks, just for example. Then 50 is the highest. So n has to be up. N is what? 5. 5 times max marks is updated. So max card has to be updated that many times, right?
Yes.
Let's see.
Ma'am, it might be we found that max card at the first step or at the second
Yes,
step or the
look,
any step.
it could be found anywhere. Okay, n could be 2, n could be 1. That means
But
only
in
once
second
max is
step
updated.
it will be found it, but only last step, ma'am. That's third problem we have a problem. It's in same that third question I have a problem with.
Third question.
Yeah,
Okay.
ma'am, in same.
This one.
Yeah, ma'am.
Okay. So based on the, okay, let me do second also because
Mm.
this is coming from second one. So
Mm.
let there be capital N cards in the pile. Assume that the pile is arranged in ascending order of total marks. So total marks in any given card is always less than the total marks in the previous card, right?
Yeah,
So assume no two cards have same total marks again. How many times will variable max card be updated if we execute the above program?
capital
So this
M.
is the same thing again.
Yeah.
N cards, so N times.
No, ma'am, not n time because increasing order means n is the last value. N is the
Yeah,
last
N is the last
value
value, right?
and we
So
found in
every
the
time
last.
yes, every time you're updating max, you're also updating max card variable, right?
But answer third question is for me.
Ma'am, what to
Now,
do if the marks are same?
no, marks, see, it is given in the data na, that no two cards have the same total marks. If there are same total marks, then the comparison will be different. Then you have to check for greater than equal to.
What
Okay,
is
not just
index?
greater than. Index is the sequence number of the card. If you
Sequence
check the
what?
card sequence
First number or
number,
second number?
No, ma'am, n is not sequence number. That is only number of time the max card
no,
is
no, no.
updated.
He's asking what is index.
Index.
Means
Index
sequence
is
means first number, second number, like that or what?
Yes, yes. You check the data set, every card has some sequence number associated with it. Okay, that is the index.
0
Oh,
to 29 it was started.
So this is the question you had problem in, right? Based on the
Yeah.
answers from the above two questions, what is the correct relationship between small n and capital N?
Yeah.
So it is saying, okay, the answer is given that small n has to be less than equal to capital N. Okay, so you disagree with this, right?
Ma'am, for less than I knowing the capital N will be means
I
that
mean,
always
you are asking how
it
small
will
n
be
can be
equal.
less than.
No, ma'am, how it will be equal then I asking for that condition only.
Okay, okay. So small n is what? How many number of times max marks is updated? And
Yeah.
capital N is what? Number of cards in the pile, right?
Ma'am, show me the answer one more time. Capital N. Yeah, ma'am, understand. I
Yeah,
understand.
capital N is number of cards, na? So it can
Because
be that the last card
capital
you don't
N will
have
be the
to
only last value of the.
see. It's simple like this. See, it can be that the first card has let's say marks 10, second has 20, third has 50, fourth has 40, fifth has 30. There are only 5 cards, let's say. So max is initially 0, right? Let's say max marks is 0. Then it's updated to 10, then it's updated to 20, then it's updated to 50. After 50, do you need to update? Because 50 is the max. So even though capital N is 5, small n is what? So as many number of times max is updated, that many number of
And
times
in
max
first
card
case,
is
the
updated.
card is in random condition. Then maximum will be found at any step. Then
Yes,
number of
yes.
capital N will be less, and it is in
Right.
ascending order. Then capital N will be
Yeah.
always greater, and must one exceptional case where they both are equal.
Yes. So when they will both be equal, when the last card has the
Last
highest.
card of first is highest.
Yes.
Yeah.
Okay.
Thank you.
Okay. Any other question from week 2?
Ma'am,
Yeah.
Ma'am,
please explain question number 1 of activity 3rd.
Activity 3, right? 2.3. Let's see.
First question.
This one.
Yeah.
Yes, ma'am.
So suppose we wish to find the shortest sentence in paragraph words dataset. So we decide to use two variables, min and count, that keep track of the length of the shortest sentence seen so far and the length of the current sentence respectively. So which is a valid initialization for min, right? So this is actually a very good thing. See, actually using this, you can understand a lot of other problems also. Whenever we are aiming for the highest or the smallest, okay, that time we have to initialize. So whenever we are trying to get the max of something, right? Max total marks, highest or most, what can I say, lengthiest sentence. So at that time, max is always set to 0. Okay, because we are going higher. We are always comparing greater, right? Or when you are when you are trying to find the minimum or the smallest, then you are trying to go lower. So in that case, if you set min to 0, then what will happen? No sentence is going to have a negative number of words in it, right? So nothing will be less than 0. So you have to set minimum to such a value which is going to be always greater than the length of any sentence. Okay, so that the comparison makes sense. If I set minimum to 0, then when you try to find, let's say the first sentence you got has 5 words in it. Okay. Then the length of the sentence is 5. Okay. But min is set to 0. So 5 is less than 0? No. In this way, even if the sentence has, like the smallest sentence, let's say, has 2 words, but 2 will also not be less than 0. So you cannot set it to 0. You have to set it to some highest value. Understood?
Yes, ma'am.
So that's why it's set
Ma'am,
to some arbitrary 10,000. Yeah.
ma'am, I have a doubt in week 1 graded assignment,
Which one?
question 5. Week
In this
1
activity
graded
only?
assignment. No, ma'am,
Week
week 1
week
graded
1.
assignment.
Okay, week 1 graded assignment. Which question?
5.
5. Okay. 1 second.
Ma'am, can we get in a recorded form?
This lecture?
Yes, ma'am.
Yeah, it's streamed on YouTube. Okay.
Uh,
See, this question you're asking? Minimum amount, average amount, this one?
No, ma'am. Ma'am, please scroll.
What is the question number? These are the 10 questions. Which one is your doubt? Hello, am I audible?
Yes, ma'am.
Yes, ma'am. Yes, ma'am, you're audible.
Yeah, which question is the doubt?
Ma'am, can you scroll the puppet up and upside? Ma'am, it's
Just
not given in your slide.
okay. But this is the same questions, right? Yeah, this is, I think, the same one only. Okay, let me check once. Let me change this.
Ma'am, everyone's graded assignments are different. So that's why,
Graded assignments are different.
yes, the questions order and something also are different for security
Okay.
reasons.
Okay, okay. I did not know that. Let's see. Here you might find. I was using the January term questions because I knew that it was the same.
She can
Just a
check
second.
from her screen.
Okay, you do that. Yeah, just share your screen and show me. This will take a lot of time. Okay, whoever's question it is, you share. I'll see.
Okay, ma'am.
Okay, in the meantime, any other question from week 2?
Ma'am, in the practice
Ma'am,
assignment, question number 5.
Practice. Okay. Yeah, anything else?
ma'am, in the question 2.7, 2.6, question number 1, the question is saying that without modifying any data in this the in this content which is given in the lecture, can we find out the maximum variable?
Which question? Let me check the
2.6
question.
question number 1. I think it is for I didn't remember the question exactly. Can you
2.6
open?
question number 1. Na? Okay,
Mm-hmm.
I'll share. One second. Visible?
Yes, ma'am.
2.6. Hmm. Which one?
The first one. Without modifying any step in the procedure given in the lecture, it is possible to
Okay, I do not exactly remember what is the procedure here. This is the procedure to find maximum marks.
It is possible to find the word that has
Okay.
maximum frequency.
Okay. Without modifying any step in the procedure, is it possible to find the word has maximum frequency? No, that step you have to go every step by step. There is no modification required, no. That is the most basic one. Yeah, one more
So
question someone asked.
the
PA.
answer should be yes, no, without any modification.
It is given no. Okay.
Hmm.
Just let me, do you have that procedure? I don't fully remember the
Procedure is they are just checking the
Yeah, but if I had
no.
the step by step, then it would be easy for me. One second. I think it will be in the slides, right? Yeah, the procedure will be in the slides. As far as I remember, there was no need for
They are
modification.
checking a paragraph. In this paragraph, they are identifying some unique words. If the words, suppose the word Monday if it's repeating, then they are just counting. They initialize the sum from 0, and if the counting are after counting is the Monday word repeating itself, then they are just adding it to the before. If there is any new variable found in the entire paragraph, then they are just adding the variable and
Okay,
they
just do
increment
one
the
thing.
count to 1.
Do one thing. Do you have that code with you?
Code.
Just that procedure.
Procedure means the lectures PPT I have.
Yeah. So if that procedure is there, just send. You can share your screen and show me once. Okay, then I'll check if it is possible or not, because I don't
Yeah.
remember the step by step.
You go to supplementary content. Lectures PPT. Download now.
Okay, which
Week 2,
right?
2.6, the first one.
Okay, let's see. Oh, okay, this thing. Yeah. So this is the whole point actually, that max in single iteration, max in 2 iterations we saw, right? So this whole 268 page slide. So there is a better way of doing it, right? That is what we learned in this whole week too. That we don't have to do it like this. We don't have to keep track of every single word. So of course there is a better way. We don't need to do this exact thing.
So we can modify the process also.
Yes. Okay, this thing obviously you can modify. This is actually the basic case, that this is how the brute force method works. That if you want to find max, this is the basic thing to do. Of course, there are better ways to do this. Yes.
Okay, ma'am. Okay.
That's why procedure.
Yes. That's the whole point. Okay. Any other? Okay. Week 2 graded or practice. Which one did you say?
Ma'am, practice assignment question number 5.
Question number 5. Okay. Let me open that. Was week 2 practice discussed or is it left?
Ma'am, I have big 3 practice assignment problem.
I think week 2 was discussed by Piyush sir once, but still, okay, no problem. Can you see? Screen visible?
Yeah, ma'am.
Yes, ma'am.
Question number 5. This one, right? It's confirmed, this question?
Yes, ma'am, this one.
Okay. So let's see what it is saying. It is saying what will B represent after the execution of the following procedure using scores dataset. Okay. So first step is what? Arrange all the cards in single pile. Okay. Second is initialize variables A and B to 0. Third step is if file 1 is empty, then we stop the iteration. So until and unless that happens, we will continue iterating from step 4. So read the top card. First card you pick up. If physics marks is not less than maths marks, then store physics marks minus maths marks. That is the difference of those two in A. Right. So A is storing what? The difference of physics and maths. In case if physics is not less than maths. or just think that physics is greater than maths. If this is the condition, if this satisfies, then A is storing P minus M, right? So if A is greater than B, then store A in B. So initially A and B are both 0, right? So let's say initially AB is 0. So let's say for some student, the first card that I picked up, some student scored 80 in physics and 65 in math. So in that case, what is the difference? 15. That is stored in A, right? So A is 15. So when I come to step 6, is A greater than B? 15 is greater than 0. This is the first iteration I'm saying. So B is now storing what? 15. Up to this clear?
Yes, ma'am, this is clear.
Next, move the current card to another pile and repeat from step 3. So next card that you pick up, let's say some student has scored 90 in physics and 70 in math. So now the difference is 20, right? So that is now stored in A. So A is now what? 20. Again, A is greater than B. 20 is greater than
Yes, ma'am.
15. So B is again updated to 20. Now let's say the third card that you pick up, someone has scored 85 in physics and 80 in math. In that case, difference is 5, right? So A is storing what? 5 now. But is 5 greater than 20? No.
Ma'am,
That
then
means B is not updated, right? So to solve this question, this is how the working is going. To solve this question, you have to go through the data set itself. Okay.
B
Okay,
will
ma'am.
represent the maximum difference between math and physics, I think.
B will represent the maximum difference because that is only way that after reaching that maximum difference, you do not have to update B anymore because any difference after that, B will not be less than A, right? Let's say the maximum difference is some student has scored 100 in physics and let's say 5 in math. So his difference is 95. So this is stored in A and eventually this will go into B, right? Because A will be greater than B. So if this is the maximum difference, after that, no matter what is A's value, no matter what difference A is storing, it will never become greater than B again. So B doesn't need to be changed. So when this will happen is when B is storing the maximum difference between maths and physics marks of a student. Understood? To get
Yes,
this
ma'am.
28 result, you have to go through the data set.
Ma'am, in week 2 graded assignment, I have a confusion in question number 6. Can you give a hint on that?
Week 2 graded is not yet submitted. Okay, I'll see.
Ma'am, only a hint, little bit.
Which one?
Ma'am, in the question number 6.
First check if this is the same question you can see. This is the question. Is this the question?
Ma'am, the screen is not visible, only
Okay,
the
okay. Sorry. Okay, check.
Yes, ma'am, this question only.
So this is asking what will be X after the execution of this. Initialize everything to 0. What is your doubt here? This is very simple question. See, you just have to update A, B, C, D according to steps 6, 7, 8, 9. Whatever the conditions are given, just update it like that. Okay. And then you have to compare with this Y variable. It is very straightforward. No hints. I can't give any hints. That will just give you the answer.
Okay, ma'am.
Just try
Thank you.
this. Main, you just have to focus on these 4 steps, 6, 7, 8, 9. Okay, any other question from week 2? Or I will go to week 3 now.
Ma'am, week 3 I have problem.
Okay. Let's start week 3 then.
Ma'am, practice assignment, ma'am.
Practice, only one person has a problem, right? Okay, fine. I'll take that. Yeah, which one you have? Practice?
Practice assignment question number 9.
Question number 9. This one.
Yeah, ma'am.
Okay, see what is happening here. Count is first set to 0. Then it is asking while table 1 has more rows, read the first card. This is on which dataset? Scores dataset only. So once you read the first card, you move it to table 2. Then you again check if there are more cards in table 1. Then you pick the second card. Okay, so at a time, in this iteration, at a time we are
Ma'am,
picking 2 cards.
ma'am, what is the
Because there is a
procedure to start the program? Either from the procedure we have to start, or from the count equal to 0 we have to start.
count. See, main thing is this procedure compare something is what this is a procedure that we are using inside this while loop, right? So this procedure is defined here. Okay, this compare something procedure is defined here, but you have to start from count. Look,
But
after I pick these 2 cards, right? Read the first row and read the first row y in table 1. Then count is equal to count plus compare something x total comma y total. So this compare something x total comma y total, this you have to go into the procedure now. Okay. So now check what is this compare something procedure doing. It is taking 2 arguments a and b. Okay. This a and b is what? These 2 cards that you just picked x and y. So x and y, whatever their total marks are, that you have to put here in place of a and b. Okay. See, that is the thing given here. Compare something x total, y total. These are arguments. Okay, this is just the definition of the procedure. Do you understand?
Okay, ma'am, then what will be written and how it will be written?
Yeah,
Explain.
look, this is why I said that let me just finish that theory part, then you will be able to answer this type of questions. Okay, since we haven't done anything like this till now. So still, I will tell you what is happening here. See, let's say the total marks in the first card is 200 and the second card that you picked is 300. Okay, so
Ma'am,
compare
the
something.
optional answer is there. That is not checking the condition. That is logical answer is there. Not any value based answer.
Let's see what happens. Forget about the options. So compare something 200, 300. Let's say. So you come here, line 13, procedure compare something. It is taking arguments 200 and 300. These are the total marks of cards you have picked. So if A is greater than B, if 200 is greater than 300, then you return -1. That means count equals to count plus -1. That means count minus 1. So whatever was count's value, it will be decremented by 1. But if in our case, A is 200 and B is 300. So this procedure will go to the else part and return 1. Right? So when it returns 1, then it will be count equal to count plus 1. So count is incremented by 1. So that will happen in both of these lines, 7 and 8. Okay. That will depend on
Ma'am,
like whatever.
if A is greater than B, then definitely B will be less than A. Then second statement
Yes,
will not.
exactly. So for one of these, it will be +1. It will return +1, and for other, it will return -1. So what will happen to count?
I think third option then, right?
So it can also happen, right? That
ma'am.
one thing can happen that 2 people have the same total marks.
Ma'am, but there is no any equality sign then.
Yes. So what happens? What happens for equal to? If A is greater than B. So if both marks are equal, then this if statement is wrong, right? So you have to go to else part, but else part is not checking whether A is less than B. That means it is including the equality option also. So whenever both are equal, you are returning just 1.
How it is showing the number of student out to miss? So the third option.
Twice the number of pairs of students who have different total marks. Okay. So I am not giving you the answer. I'm just telling you how the procedure is working. Okay. Now let's see what will happen. So count, let's say this happened. Okay. All of these cards we have been through. So move Y to table 3 and then at the end you move all the rows back to table 1. So after comparing all pairs of cards, what this is finding? What is count going to be?
Ma'am, but during the exam we have
Shall I answer?
time to compare all the value, ma'am.
No. You don't have to compare all the value. No? This is not based on values. This question is
Ma'am,
not based
shall
on
I
data set.
answer?
Yes, answer.
Ma'am, shall I answer?
Yes,
See, ma'am,
yes.
for the if A is greater than B or B is less than A, for first case it will be returning -1, and for second case it will be
Look,
returning 1. So both will cancel out each other.
anytime X and Y are different. One will be
Yes.
positive,
So
one will return positive, one will return negative.
negative. So these two will cancel out each other. But when we are
Exactly.
getting that equal to count, then these two counts will be incrementing them 2 times.
Correct. So which option this is?
And third option, twice the number of pairs of students. Why this?
Twice the number of pairs of students who have different total marks. That is the answer given.
Oh,
But I think it should be number of pairs of students who have same total marks, no?
Same total marks, ma'am.
Yeah, I think this should be the answer. Okay, let me check once what is given in the solution. Because count is only going to be incremented whenever some students have the same total marks, some pair.
Ma'am, one thing more I want to ask, where you are checking this solution part?
It is given on the top only. Yeah, which question was this? Question number?
9, man, 9.
9.
Question number 9.
Yeah. See, solution is given. Count will be incremented when x total equal to y total. Yeah, that's what I said. So how is it twice the number of pairs of students? This is the number of students, number of pairs of students having same total marks. No? Don't think this is correct.
No, ma'am. See, ma'am, if in the first count, if we will compare
Wait,
that A is
just
equal to
one
B,
second.
then it will be 1.
Just a second. Now let me just once
You
check
will be
this
compare the
properly.
whole data set, then one hour
So
will be
first,
passed in one
one
question.
second. If x is greater than y, okay, then first it will return -1. If x is less than y, it will return +1. If equal, then also it will return +1. So now because of two successive procedure calls with different order of arguments of comparisons, results 1 and 2 will nullify each other's effects. But due to result 3, count will be incremented twice. So what happens here? When you have two same total marks, x and y are same, then count is incremented how many times? 2 times, right? In step 1, once count is incremented. In step 7, once count is incremented. Again, step 8, count is incremented. So for every pair of student who have the same total marks, count is incremented how many times? Twice.
Means for same total marks.
See, x and y is equal, okay. If x is equal to y's total marks, then compare something procedure will return what? 1. So count is incremented once in step 7. Again, when you go to step 8, it is the same thing will happen. Only the order of parameter is different. But comparison will be same, right? So it will return 1. So for every pair of students who have same total marks, count is incremented twice. That's why it is twice the number of pairs of students who have same total marks. So D option will be correct.
Okay. And ma'am, that same question, same assignment, last question, I think. Yeah, ma'am, last question.
This question. No, last is.
Yeah, ma'am.
Okay, this one. No, this question I won't tell you now. First, let me finish that thing. If I don't give you the theory, this will not be okay for others to understand. Okay. Okay, now let's start week 3. So first thing in week 3 that you need to know is week 3 is mainly about scores dataset. Okay. So one thing we will learn which is very important is your 3 prizes problem. But before that, let's just get some context. So this is very basic thing. It is saying that how each card can be like the data you can extract from any card and you can put it in the form of a table, right?
And
So
ma'am,
this
one
is
more thing, where you are getting these slides and these solutions?
slides are there in your supplementary contents. Okay, PPT slides are there.
And solution slide. What
Solution for PA is given in the beginning of the PA assignment only. If you cannot see it, is it visible for all of you, the PA solutions?
Yes, ma'am.
Okay.
And supplementary content are showing.
Yeah, just a second, I'll show you. Okay, let's just discuss this first. It is already 7. No? See. So this is one scores dataset card. Okay. So what are the fields that I have in this card? What fields do I have? One is the name field, one is the ID field, gender, date of birth, town, city, maths marks, physics marks, chemistry marks, and total marks. Correct. So all of these fields I have put in the form of a table. Okay. So in this card, ID is what? 10. So beneath ID, you write 10. Name is Kavya, gender is F. Whatever values are there, you just put in the form of a table. So this I can do for any card, right? Even in the words data set, paragraphs data set. What are the fields in paragraph? ID, word, what is the type, that's part of speech, and letter count. So these are the fields and this is the data. This same thing you can do for any shopping bills, whatever data set is there. Okay. Now, next is now from here we will learn the pseudocodes. See, first thing is sum of boys' maths marks. Okay. How to find the sum of mathematics marks of all boys. Okay. Is the screen visible?
Yes, ma'am.
Yes, ma'am.
So in this flowchart, first terminal is saying start. Okay. First, let's go through the flowchart, then we will go to the pseudocode. So first start, then sum variable. Sum is a variable which is assigned the value 0. Okay. Next, there is a decision box. Are there more cards in pile 1? If yes, then you come here, you pick one card, that is the top card, and you read that card and you move it to pile 2. Next decision box is asking the card that you pick, is the gender of that card male or female? That is, it is asking, is the gender male? If yes, then you will add the sum of mathematics marks of that card to the sum variable. So sum equals to sum plus math, x dot math. Okay, x is the card that you pick. So if gender is female, then what will happen? Then flow will go to this way, right? No, and it will again pick the next card. So when will this procedure stop? When will we go to the end terminal?
All cards are on.
When all cards are done, right? So what is this doing? This gender M, why am I doing this? Why am I checking this?
Sum of all
For
boys.
boys marks.
Maths math.
Because we want to find boys' maths marks, right? So that's why to filter out only the boys, we are using this decision box. And where are we adding the sum? That is where are we adding? Here. In this procedure box, we are adding sum equals to x plus math. So every time you find a boy's card, you will add his mathematics marks to the sum variable. Now this exact flow chart is now written in the form of pseudocode. So first sum is 0, while pile 1 has more cards. This is corresponding to this decision box. Okay. So as long as pile 1 has more cards, you pick the first card x, move x to pile 2. If gender is equal to m, this is this decision box. Okay. If gender is male, then you add the sum. So at the end of this procedure, sum is storing the total maths marks of all boys in the data set. Clear? Any question in this procedure? Okay. So next, this is the same thing. It is asking now, what if we want to sum the maths marks of girls? Then what is the different thing that we need to do?
In place of boys, we have to put girls.
Yeah, just in place of boys, we have to put girls. Or one more thing we can do is, if gender is M, then we will just put if no. Okay. In this no and yes, we can swap, right? So if no, then I will add the marks. If yes, then I will pick the next card. This also we can do, right?
Yes.
Is this understood? Yeah.
Yes, the conditions will be interchanged.
Yeah. One thing you can do is you just put F in place of this, but I'm also saying that you can just rearrange this. That is, yes is placed in place of no, and here I can put like every time this is no, then I will add the sum. And if it is yes, I will pick the next card. That is also going to give the same result. But here, obviously, they have done the
In that
simpler thing.
in that case, we will consider no as true value.
Yeah, like if no, see, it is not like true value. Okay, yes or no, whatever is the answer, you go with that flow. So if here I place no instead of yes.
That
So what
means
happens?
that means
Gender is male, no. So you will come here. And if gender is male, yes, then you will pick the next card. This also I can do. Right? Same thing.
Yes, I
Although
can.
this is not done here, they have just placed F, but I am just giving you an alternate. So if gender is female, then yes, you add the sum of marks. Same thing, just change the gender. Next, they're asking what? These are all same things. So just a generalization is that instead of putting whatever that is
Ma'am,
your male or female, you can just put gender here. So
ma'am, if we have 2 or 4 continue if statement, then if first condition is true, then we might don't have to check other condition.
no, it doesn't work like that. See, if it is a nested if, then you have to go in. Okay. If the outer if is true, then you go to the next if. And if there are not nested ifs, if they're just if else statements, so they are all independent of each other. Okay, you have to go through all the ifs.
Okay.
Okay, see this one. Procedure to sum up max marks. Now I am writing this as a more like a proper procedure. See. So now I am naming this procedure as sum max. This is the name of the procedure. What did I say this is called? This within parentheses, what is this called?
Parameter.
This is a
Argument.
parameter or an argument, correct.
Ma'am, sorry to
Parameter or
interrupt.
argument.
Ma'am, but I have some doubt in static section. Can I leave this class?
Sorry, I cannot hear you.
Ma'am, I have some doubt in static section that is already going.
Yeah, sure. If you don't need to attend this, fine, you can watch it later on. Okay, no
I
problem.
completed my bit.
Yeah, no problem. See, okay. So procedure name is sum maths. So in sum maths procedure, what is our argument? Gender. Okay. So in place of this gender, you can either place male or you can place female, and similarly, this value will be changed. Okay. So instead of just writing a procedure just for male or just for female, you can write a procedure in general and pass the gender as an argument. Okay. So this rest of the procedure is absolutely the same. Just instead of writing male or female here, we are writing gender, and this gender will be taken from this value. That is, whenever you're calling this procedure, you are going to pass the male or female gender as an argument. Understood? And after performing this procedure, whatever is the sum that will be returned to the main function call. This is wherever you called this procedure. See. Same thing. Like here, call procedure with parameter sum maths f. What will this return? Anyone? What will this
Female math
return?
marks.
Female, sum of female maths mark.
Sum of female maths marks. Right. Okay. So I guess this is clear.
Ma'am, here we are taking input from the user, whether it's
Yes.
male or female.
Look, whenever you call a procedure, okay, whenever you call a procedure, you can pass the argument. So here the argument is what? Gender. So whenever, let's say in some program, I am calling this procedure, I need to find the, let's say, sum of male maths marks. So whenever I call it, let's say I want to store whatever this procedure returns in a variable called A. Okay. So here I will pass A equals to sum. Okay, this is for physics. So sum physics. And I want to find it for females. So I will write F. Okay. Like this, I will pass. So once I write this, the control will shift over to the actual procedure. And here, instead of gender, it will take female. Okay, it will calculate the sum of total physics marks for females, and it will return that sum. Where is this sum returned? To A. That is, after this procedure is done executing, A will now store the sum of female physics marks. Clear?
But in this procedure, ma'am, we are not defining A here.
No. This is just some external. Okay. You call a procedure in a function. Like that last example that we saw in practice assignment, the procedure was defined separately, right? Just like that. In the main function, you can call a procedure. Okay, let's say
Okay,
this
ma'am.
A is part of the main function. So you called this procedure sum physics. So at the moment when you call this procedure, the control will shift over to the actual procedure definition. And instead of the argument, it will take whatever argument the user inputted. That is this one. Okay, so once it returns the sum, that sum will be stored in A variable. That is wherever you call the procedure. Clear?
Okay, ma'am.
See, similarly, this I can do for male, female, both. And this is very simple. Okay. So now we have found two different things. One we can do is sum of maths marks for male or female or sum of physics marks for male or female. Now it is saying a procedure to sum up any type of marks. Any type of marks means I can either sum up male or female marks, and it can be for any subject, maths, physics, chemistry. Now, if I want this type of generalization, then my procedure needs to have two arguments because there are two variables here. One is gender, one is field or subject. Okay. So that's why, see, in this procedure, there are now two arguments, gender and field. So gender can be what? Male or female. Field can be what? Maths or physics or chemistry. Right. Even you can give total marks as a field. So how will this work? See, sum is initially 0. If pile 1 has more cards, you pick the first card. Then move it to pile 2. If gender is whatever gender you have specified here. Let's say I have specified female. So if gender is female, then I will come here. Sum equals to sum plus x dot field. This field value will be whatever you specify when you are calling the function. If you specify maths, then it will be x dot math. If you specify physics, it will be x dot physics. Right. So this is generalized for any subject, any gender. Clear this procedure?
Then why this gender is required here? We can directly sum the total without taking any gender.
No. See, this is for the
generalized
requirement, whatever requirement you have. If you want to find female physics marks, then here you will, in place of gender, when you are calling the function, you will put F. In place of field, you will put physics. This is a general procedure to find any type of marks for any gender.
Ma'am, it's a user required program. What user want to do?
Yeah, definitely.
That's
Any program is up to user requirement, whatever you need to find out. Now you will
but here
understand
we are
why.
generalizing, no, ma'am.
Yes, of course you're generalizing, but you will see why I am generalizing this. Okay, this is just part of a bigger program that we are going to come to. I just need you to
Oh,
understand the components first. This is one of the components. Okay.
okay, ma'am.
So we will need to actually find the sum of marks for all subjects. That's the thing. That's why we are doing this. Now, one more filter I have added here is gender. So you can find the total marks for any subject for both male and female using this procedure. See, two parameters, gender and field. So this, in this procedure itself, do you have any question, like any step you're not understanding? Or I will just go to the next procedure if you don't have. This is clear for everyone? Yes, no, anything?
Yes, ma'am.
Yes, ma'am.
Because there are a lot of repetitive slides here, so I'm not going to go through those. See, this is how you call, okay, sum marks F chemistry. This will find sum of chemistry marks for all girls. Sum marks M physics. So sum of physics marks for all boys. Like this. See, now girl chem sum. Okay. This is a variable. In this variable, I am calling this procedure sum marks F chemistry. So whatever is the sum of chemistry marks for all girls, that will be stored in girl chem sum. How is this stored here? Because there is a return statement, right? Which is returning the sum. If this statement was not here, then nothing will be returned by the procedure. Then girl chem sum, this variable, it won't contain anything. Understood? When you actually go to high level languages like C, okay, you will see that there are some procedures for which there is a return 0. Okay. That means that procedure is always going to return 0, nothing else. So
Low
this
level.
returns. No, programming languages are higher level languages, no?
Yes, ma'am. But C is comparative to lower level, no?
Yeah, you can say that. I mean, I'm not doing a comparison between different programming languages. I'm just saying that in terms of.
Machine code.
Sorry?
You are just saying the programming language, the whole concept is higher level.
Yes. That's what I'm saying. That compared to assembly level or machine level languages, programming languages are higher level. Okay. So whenever you learn any type of such language, you will see that whenever we write a procedure, there is usually, in that case, it is called a function. Actually, we call it procedure here. So every function will have some kind of a return statement. Yeah. Like here, we are returning the sum. So just because this statement is there, only that because of this statement, this sum is being returned to this variable. Okay, otherwise it won't be. Similarly, boy chem sum means this procedure sum marks will find the chemistry marks sum for all boys and store it in this variable. Now see, if there is a statement like this, if girl chem sum is greater than equal to boy chem sum, that means girls have scored greater than or equal to total chemistry marks than boys. Then congratulate the girls, otherwise congratulate the boys. Like that. Okay, it's just a procedure example.
Ma'am,
Yeah.
the return will return the sum where the
Wherever it is
procedure.
called. Yeah, wherever the procedure is called, to that variable it will return.
Okay, ma'am.
Like here, this variable it is calling now girl chem sum equals to sum marks F chemistry. So the return value will also come to this variable only.
Okay, ma'am.
Yeah. Okay, so calling a procedure is clear, I guess. See.
Yes, ma'am.
Now this one is saying this part is done. Then there is some sum equals to 0. And it is saying update marks 17, physics 88. Okay. So this is probably some update marks procedure, which is going to go to this card number, I guess. This will be for sequence number. So sequence number 17, it will update the physics marks to 88 marks. This is also some procedure that we are calling. But see one thing, this update marks procedure is not called inside any variable, right? This is not assigned to any variable. That means this will not return anything. This procedure will just update the marks, right? So there will be no return statement here. The update marks is associated with any variable or it is just called?
It's just a variable.
It's just called.
It's just called. Like here, girl chem sum was a variable inside which we were calling this procedure. But here, just the procedure is being called without involving any variables. Why? Because there is nothing to return. We are just updating the mark. That's it.
Ma'am, whenever we call procedure and initialize it to a variable, assign a variable to it, then only the return will return the value.
Yes, then only it will return some value, because whenever you're returning a value, that value has to be stored somewhere. Na? So if you don't assign it to a variable, where will the value go? Like here,
Okay.
update marks. It is not returning any value. It is just updating the marks of this person with sequence number 17. Her physics marks is updated to 88. But there is nothing to return here. That's why no variable is involved.
Okay.
Okay. So this 2 point, this is I think 3.6. So any question from these slides till now? Everything is clear?
Yes, ma'am. Yes, ma'am.
Okay. Okay. Now let's go to the next one. Rest is just summary. This is more important. Is it visible?
Yes, ma'am.
Yes, ma'am.
Okay. Now see, now we will come to the main part of that three prices problems that I was saying. Okay. This week is actually mainly about this three prices problem. So let's take a little insight first. Three prices problem, what this problem is. There are three different parameters that we have to keep in mind. First thing is, three prices problem is a problem where we have three different prizes to assign to top students. Now, what is the criteria to find those top students? There are three criteria. One is the total marks. That is, the three top students in class should have the highest total marks among other students. Okay, that is the first criteria. So first criteria is total marks. That should be highest. Second criteria is what? That those students, those top 3 students, could have scored highest marks in any of the subject. At least one subject should have scored class highest in at least one subject. Okay. And third criteria is that since there are 3 places, 3 prizes we have to give, so at least one should be a boy and at least one girl. So these are the 3 different criteria for 3 prizes problem. One is
Ma'am,
total marks should be greatest. Yeah.
can you repeat the first criteria?
See, total marks. Okay, there is a field called total marks in the cards. Right. So that total marks of the top 3 students should be greatest in the class. Okay. Now,
Okay.
if it is seen that in the class no 2 students have the highest total marks as same, okay, then it can be the top 3 highest marks, top 3 highest total marks. But whatever it is, it should be greatest in class among the top 3. Second criteria is that these 3 people who are going to get the prize, they should have scored highest marks in at least one subject, either maths or physics or chemistry, or they could have scored highest in all 3 or any 2, but at least one they must have. Okay.
And their
Third,
total should also be the greatest
yes, total
in
should
the
also
top
be
3.
the highest. Yes. Now it can happen that the top 3 students have scored different total marks, but they are still greatest in the class. Okay. Third criteria is what? That among those top 3 people, at least one should be a boy and at least one should be a girl. It should not be all boys or all girls. Okay. It can be 2 boys, 1 girl, or 2 girls, 1 boy. That is also fine. So this is the criteria. Now, analysis of top students. Now, whatever procedure we learned till now is because we want to analyze these top students. And for that analysis, we need to know the maximum marks, all these things. Okay. So this 3 prizes problem has a lot of components. We'll learn one by one. Is there a single student who is the best performer across subjects? That is the first question. Second question is the highest overall total same as the sum of the highest marks in each subject? Now let's say the sum of highest marks in maths is 100. Okay. In the entire class, some student has scored 100 in maths. Again, some student has scored 100 in physics. Again, some student has scored 100 in chemistry. So what is the sum? 300. But the highest total marks in class is 290. Can this happen?
Yes, ma'am. Happen.
Right. So this is the topper student, but he hasn't scored 100 in all 3. Right. But this student's total marks is the highest. Okay. Next is need to compute maximum for different fields in a scorecard. So to find out about all those criteria that I just mentioned, you need to know what is the maximum marks in each subject, right? To know who is the top student. Because the top student has to score maximum in at least how many?
One subject.
At least one. So for that, I need to know what are the maximum marks. So I have to find the maximum for maths, physics, chemistry, as well as total. Because total marks is also a criteria, right? The first criteria, maximum total. Now see, ideally suited to using procedures, same computation with a parameter to indicate the field of interest. That means whenever I try to find the maximum mark in any subject, I don't need to write a separate procedure. I can write a procedure in general and I will just change the parameter to maths, physics, chemistry, and total, right? So that procedure is this procedure max marks. So this procedure is going to find the maximum mark, keep track of the maximum mark using a variable. Okay, this max val is the variable that will store the maximum marks, which is first initialized to 0. This field or this argument can be set to whatever subject you want, maths, physics, chemistry, or even the total marks. So while pile 1 has more cards, you pick the first card, move x to pile 2. If x dot field is greater than max val, so let's take an example. The first card that you pick, okay, let's say this field is for math. So I have called this procedure using maths as parameter. Okay. Now the first card that I pick, someone has scored, let's say 60 in maths. So first card M1 is 60. So is 60 greater than 0?
Yes, ma'am.
Yes, ma'am.
So max val will contain what now? 60.
60.
Now let's say we go to the next one. Next card I pick. Someone has scored 17 max. So again 70 is greater than 60 now. So again this
Yes.
is now updated to 70. But the next card that I pick, someone has scored 45. In that case, will I update max val?
No, ma'am.
No,
No.
ma'am.
So
Only
at the
70.
end of correct. So at the end of execution, maximum value will have what? The maximum marks in mathematics. Correct?
70. Yes, ma'am.
Yes, ma'am.
So this procedure you can do for any field. Okay, maths, physics, chemistry, or even the total mark. Now see, analysis of top students. So using this max marks procedure, whatever value is returned for mathematics, that I am storing in this variable max maths. Understood? So procedure is called in this variable, so the return value will be stored also here. Again, for max physics, I'm calling the same procedure with physics as the argument. So that value will be stored in max physics. Again, same for chemistry, same for total. Okay. These four things. Okay, first four. Do you have any confusion here? Any question?
No, ma'am.
See, just even if you don't have any question, just tell me no,
Here
okay, so
we
that
are,
I.
ma'am, excuse me.
Yeah.
Here we are only we are only getting the maximum marks in each subject, and
Right.
whoever is the student, we don't know.
No, we don't know yet. We are
Yeah.
just calculating what is the maximum marks scored, and we are storing that marks in these variables. Okay. Next, see, subject total is a variable which has the sum of these maximum marks in maths, physics, and chemistry. So subject total is containing the sum of total highest marks in maths, physics, and chemistry. Like I said in that example, that if some student has scored 100 in maths, some has scored 100 in physics, some has scored 100 in chemistry. So what will be subject total? 300, right? Because
300.
that is the maximum marks. Next, if max total is equal to subject total, then it is a single topper. Okay. This means what? What is max total? First tell me. What is max total storing? What is max total storing?
Highest total
in the class.
Highest total marks in the class. Is there an equal to condition in this procedure? In this maximum marks procedure? No. That means if two students, okay, if two students have the same marks, if two students have the same total marks, then what will happen? This condition will be false. Correct?
Yes, ma'am.
So that's why it is saying that if max total is equal to subject total, that means there is a single topper. That means there is a person who has scored this 100 in all three, according to our example. Okay. So that's why single topper is true. But if I see that maximum total is different than subject total, then there can be multiple toppers. That's why single topper is false then. Okay.
Ma'am, if two persons got the same score,
Hmm.
whose total it will store?
See, if two-person have got the same score, then there is no single topper, first of all. Then there will be multiple toppers. Okay. So that's why single topper is then set to false.
It is only for max total you are giving.
Yes,
If
yes.
subject total is there,
If subject total is there, we don't care, right? Because we in subject total, we don't care who has scored. We just want the maximum mark. Okay. So even if two people have scored the same mark, same highest, we don't care about that. We just need the highest mark. Here we are comparing whether that total mark is equal to subject total. That is whether someone has scored the total marks that is same as the subject total. If this is true, then single topper will be true. Otherwise, single topper is false. See, this will make sense when I complete this procedure. Wait. Okay, this is already summary. Let's go to the next one. Okay, see, these slides, be very attentive. Okay, this is the most important part. Look, now we want to know how are we awarding the prizes. So basic criteria is total marks, like I said.
Ma'am,
Whoever
no
those.
screen available.
See.
Okay.
My
one
screen
second.
not visible.
Yes. Great. Now,
Yes, ma'am.
Yes, ma'am.
see,
Visible.
basic criteria is what? Total mark. Okay. Like I said, 3 criteria are there. Basic is total marks should be highest. Next, must also be within top 3 in at least one subject. That is, must have scored among top 3 marks in at least one. And must select at least one boy and one girl for the top 3 prizes. Right? These are the 3 procedures. So, see the second one. Must be within top 3 in at least one subject. That means for every subject, I need to know what are the top 3 marks in that subject. Correct? So in maths, I need to know what is the first highest, what is the second highest, what is the third highest. So the topper that we assign the prize to should have scored within these top 3 marks in at least one subject. Understood? That highest that I was talking about is actually top 3 highest. Okay. Since we haven't yet found out how to find top 3 in a subject, that's why I was not using this top 3 term. But see, you have to check whether a person has scored among top 3 in at least one subject. So for every subject, now we have to find what are the first 3 highest marks. Okay. So before we go into all of this, let's find the maximum. Look. So how to find top 3 marks in a category? That is in math. If I want to find top 3 marks, what is the way? So initialize a variable max to 0. This is how we find maximum, right? We take one variable max, we assign it 0, and then we go through all the cards, and every time we see a bigger value, we update max, right? This is how we find maximum. How do I find second max and third max? So we need 2 more variables. Okay, second max, this is for top 2 marks, max and second max. And for top 3 marks, we need 3 variables. Okay, max, second max, and third max. Now, how that change is done, see. Finding first, let's say top 2 marks. So now I need 2 variables. Max will store the first
Ma'am,
highest.
we have to continuously updating the max value. When we find first max, second max, third
Everything
max.
you have to update actually. First max, second max, third max, everything will be updated. I will show you the whole procedure. First see. Max and second max. Max is going to store the highest, first highest. Okay. Max is going to store the first highest. Second max is going to store the second highest. If current card value is bigger than max, okay, let's say for mathematics, we are trying to find the first and second max. Okay, so the first card I have picked, initially max, second max, both are 0. Okay, now let's say some card I have picked who has scored 60 in math. So this 60 value, it is greater than 0, right? So copy max to second max and update max to current value. So now initially max was 0, second max was 0. Now I picked some person X's card whose X dot max marks is 60. Clear? So first I will compare it with the maximum marks. So is 60 greater than 0? Yes. So now max will contain 60. But remember, whatever was stored in max should go to second max now. Since both were 0, so there is no need to write that comparison here. Second max will remain 0. But next card that you picked, let's say some person has scored 80 in max. Okay. Now again you have to compare this 80 with the current max value. What is current max? 60. So is 80 greater than 60?
Yes.
Yes.
But if I now directly update the max value, then what will happen? This 60 will be lost. But this 60 is currently our second max, right? Currently it is the second maximum we have come across. So first you have to store max's value into second max. So first second max will be updated to 60. Then you can update max to the current value. So max will now be 80. Again, let's say you picked one more card whose x dot max marks is 90. Now what will happen? Any of you tell me? How will the
90 will
update
be
go?
max and 80 will be the second max.
First, what will I do? First, who will I update?
First,
Second
second
max.
max.
First max.
First, I will update second max after the comparison, since I know that max needs to be updated. But I don't want to lose this value, na? Because this is my second highest, whatever is stored in max currently. So first I need to store this into second max. This 60, I can lose it. I don't care about it now. I only need the top 2 marks. So in second max, first I will store 80. Then in max, I will store 90. So what is the general code? Anytime x dot max is greater than max. This is the comparison we are making, na? So anytime x dot max is greater than max, first update second max to current max. That is second max, assign the value of current max. Then assign current max to this x dot max that we just saw. This is the code. Understood? Is this part clear how the updating is going?
Yes, ma'am.
Yes, ma'am.
Everyone, right? Yeah, ask.
And third max is a 60 in this value.
Sorry? Again, come again.
Third max is 60 in this case.
Yeah, if I had that third max variable, then it will be 60 at this point. Okay, but currently we are just taking top 2 marks. I haven't gone to top 3 yet. So we just have 2 variables, max and second max. Okay. So in this case, 60 is now lost after I made this transition. Now second max is having 80, max is having 90. I'll come to third max also, see. Now, one more case that can happen is
Ma'am,
if
max is
current...
having 80, na? Why you say 90?
No, I changed it, na, that you read a third card who has scored 90 in max.
Oh,
Okay, in that case, that will be stored in max, highest value. Now, one more thing that can happen is if current card value is between max and second max. So in our example, let's say you read a fourth card, x dot max in that card is 85. So some student has scored 85. So first you do this comparison. Is 85 greater than max, that is 90? No. Right? Then what will you do? Any idea?
And compare it with second max.
Right. Then just go to the next value. That is, go to second max and see, is 85 greater than 80? Yes. So I will update second max to what? X dot max. So 2 situations are there. Actually, more than 2. There are 3 situations. One is what? When your current card's value is greater than max. In that case, you have to first assign max to second max and then current value to max. Second situation is that your current card value is between max and second max. That is, it is less than max but greater than second max. In that case, there is no need to update max, only update second max with the current card value. Third situation is what? Your current card value is less than second max also. In that case, there is no need to change any of the variables. Clear? Three different situations can occur. Right?
Okay.
Yes, ma'am.
Look, this will become clearer when we do the procedure. Okay. Now, this same basic procedure for 2 marks, I can change this to top 3 marks also, right? You can generalize this to any number, top
Yes,
3,
ma'am.
top 4 marks. So now let's do it for top 3 marks. So this is the procedure name, top 3 marks, and subject is you can input for whichever subject you want. Okay. Let's say we are doing for math. First call, I have called this top 3 marks procedure with parameter math. So initially you need 3 variables, max, second max, third max. Initially assign them all to 0. Okay. Next, while pile 1 has more cards, pick a card X from pile 1. Okay, I'll just skip this. I'll go to the entire procedure so that you can see what is happening. Where have they written the entire thing? Yeah, this one. This is the total procedure. Okay, instead of breaking it down like that, it will be confusing. So let's see the whole procedure together. So initially max, second max, third max, all have zeros assigned to them. Fine. Second. All have zeros. Next, while pile 1 has more card, let's say we are picking the first card from pile 1. Okay. Now, first card, whatever the x dot subject, here subject we have taken, let's say math, for example. So whatever the maths marks is, if it is greater than max, then what will you do? Let's take an example. First, all three are 0. First card I have picked, someone has scored, let's say x dot math is x1 is 60. That is first card, someone has scored 60 in math. So is 60 greater than max? First iteration I'm talking about, when all three are 0. So 60 is
Yes,
greater
ma'am.
than max. But see,
Yes, ma'am.
we have written these 3 steps. Even though in the first iteration this doesn't make sense since all are 0. But still you are going to write that third max we are going to assign what is stored in second max we are going to assign what is stored in max. Then in max we are going to assign the subject mark. So after this, what is max containing now? 60. Right? Second max is still 0 because max was initially 0. Third max is also 0 because second max was initially 0. This much is clear?
Yes, ma'am.
Now next card we are picking. Okay. Next iteration. Next card is, okay, you have to go through these two if statements also. Okay. But since this one is already satisfying, but still if you want to check, go here. So 60. Okay. So now max is 60. This also is 60. And second max is 0. So this condition is wrong, right? 60 is not less than 60. Again, go to the next if. Second max is 0. Okay. So go to the next if. Second max is 0. X dot subject is 60. Third max is 0. This also is wrong. So this if statement will also not be executed. So we will go to pick the next card. Let's say next person has scored 65. Okay, currently max is 60, second max is 0, third max is 0. So now again check, is 65 greater than max? Yes or no?
Yes, ma'am.
So first what we will do, in third max, we will store second max. What was second max? 0. So third max
0.
remains 0. In second max, we are storing max. What was max previously?
60.
60.
So now second max is what? 60.
60.
And in max, we are going to store the current subject mark. That is,
65.
max is now 65.
65.
Again, if you check these two conditions, you have to check because this is the program flow. So you have to go through all the ifs, but these statements will be wrong because the condition is not satisfying, right? So next, pick up the next card. Let's say the next person has scored 70. So in that case, now, what is max? 65. So is 70 greater than 65? Yes.
Yes.
Yes, ma'am.
Okay. So again, do this. Now third max is containing second max. What was second max?
60.
60.
So third max now is 60.
And
Second max
is
now is
65.
65.
65.
Correct. And max is
70.
70.
Good. Now let's say next person whose card you are picking is X4. Let's say this person has scored 68. Okay. So is 68 greater than 70? This condition we are checking initially. No.
No, ma'am.
No, ma'am.
Then go to the next if, this if. Now let's check what is max. Max is 70. And the subject max is 68, current card.
68.
Second max is what? 65.
65.
So this
65.
condition is satisfying. 68 is
Yes,
less
ma'am.
than 70, greater than 65. So you execute these statements. Third max is updated to second max. What was second max? 65.
65.
So now third max is 65. And second max is the current subject max, that is 68.
68. 68.
And max is not at all changed, right?
Yeah.
Because max is still 70.
Yeah.
Okay. So at this point, max is 70. Second max is 68. Third max is
60.
65.
5.
Yes. Okay. Now, after this, You also have to check this if condition, all the ifs you have to go through, but this will not be satisfied. So next card that we pick is, let's say someone has scored 62, or no, let's say someone has scored
66.
66, right? If someone has scored 66, then is 66 greater than the current max value, that is 70? No. So this
No,
is
ma'am.
wrong, not satisfying. Now come to the next if. Max is 70, second max is what, 68, and current subject is what, 66. Is this condition
66.
satisfying?
No.
No, ma'am.
No, because 66 is not greater than 68. So come to this if. Here, second max is what? 68. Subject is what? 66. Third max is what? 65. Is this condition satisfying?
Yes, ma'am.
Yes, ma'am.
So just perform this statement. Only update third max. Third max is updated with what? The subject max. So third max is now what? 66.
66.
So max is, after this iteration, max is 70. Second max is 68.
68.
Third max is 66.
66.
Understood. Now, let's say you pick one more card. Someone who has scored 80 in max. Now what will happen? Is 80 greater than max?
Yes.
Yes, ma'am.
So first third max will contain whatever is stored in second max.
Second
That means
max.
third max is now what?
68.
68.
68. Second max is containing max. That means
70.
70.
And max is containing what? Current
80.
card. 8. Is this clear to everyone how to find the top 3 marks for any subject?
Yes, ma'am.
Yes, ma'am. All clear.
See, when this procedure ends, you are going to return only the third max value. You know why? Because once you return the third max, you know that the other 2 top marks are greater than this, right? Third max is less than second max and max. So any person who has scored greater than third max or greater than equal to third max is among top 3 in that subject, I can say for sure. Right?
Yes, ma'am.
Yes, ma'am.
Any person who has scored greater than equal to third max is among top 3 in that subject. Okay. So only returning third max is enough. Okay. This was the main thing. Okay. Now, see. Now we have to deal with this boy girl thing. Okay. No, now we will deal with top 3 totals such that top 3 in at least one subject. This was our other condition, right? The total marks problem we dealt with. Second problem was what? That the person should be among top 3 in at least one subject, right? So this is the problem. So we will again maintain max, second max, third max. How this will work, see. Instead of reading all this, just let's see the procedure.
Ma'am, for giving the top 3 prize, we need to write such 3 kind of procedure.
Yes. For finding this 3 prizes problem, okay, to solve this 3 prizes problem to find the top 3 students, told you that this procedure has a lot of components. This thing that we just learned, top 3 marks in a subject, this is just one part of that. This is
First
just one
criteria.
component. Yeah. No, first criteria was the total marks. Okay. That subject total that we did. First criteria was
Okay.
total marks. This is the second criteria, that the person should have scored among top 3 in at least one subject. This is the second one. That at least one should be boy, at least one should be girl. That is the last criteria that we will come
Okay,
to.
ma'am.
Okay. Now see. Let's start from here. So we have max, second max, third max. And we also have max ID, second max ID, third max ID. This why do we have? Because now we want to know who are these people who have scored the highest, right? So we want their ID. But why have I assigned -1 and not 0? Because sequence number is starting from 0 itself. So it can happen that a person who has scored the highest among top 3 in a particular subject has sequence number 0 or ID 0. So in that case, if I have 0 only, then the comparison will not work. Okay. So that's why I have picked -1 for all 3. ID starts from 0. Okay.
So we are initializing from -1
Yes.
or say
For
max
the
ID.
ID part, we are initializing all to -1 because actual ID start from 0. Okay. So we cannot initialize it to 0 because 0 is actually the ID of some student. Okay.
Ma'am, then how we will get the correct
Yeah, we will
means
see.
ID?
See how this
Okay.
works. So maintains max, second max, third max, as well as the IDs corresponding. Record third highest mark in each subject. So we know that top 3 marks procedure returns only third highest marks, correct? Because anything above that automatically means it's a topper in that subject, right? So now we have 3 more variables: maths 3, physics 3, chemistry 3. These will store what? The third highest in each of these subjects. See, the procedure call is for top 3 marks. And top 3 marks procedure returns what?
Third highest.
Third highest.
Third highest in that particular subject. So maths 3 will contain what?
Third
Maths,
highest mark
third
in
highest
maths.
mark.
Similarly for physics and chemistry. Okay, this is the initialization. Now see, it is saying, see, first we did 2 initialization, one for max and max ID. Another is the third highest per subject. Now we are checking while pile 1 has more cards. Now you pick up, now we are going to scan through all the cards. Okay, let me go to the entire thing. One second. Okay, so first pick one card. Now we are scanning through all the cards. Okay, first pick one card from scores dataset. If subject topper is a procedure, okay. If subject topper X, maths 3, physics 3, chemistry 3. These are what? Third highest in these subjects. And X is the card that you pick. Okay. These are all arguments to this subject topper procedure. If this is true, if this procedure returns true, we don't know yet what is this subject topper procedure. Okay, this is some new procedure. But we are just saying that if this returns true, that is, if this if statement is true, then if X dot total, that is whatever is the total marks scored by this person whose card you have picked, is greater than max. Max is what?
Maximum marks.
What was, when we initialized max, what was max? See, here we did the initialization. What was max? All are initialized to
Max
0.
0.
And IDs are all initialized to -1. Okay, remember this. See, now it is checking if this procedure, whatever this subject topper procedure is, if it returns true for this X card and these other arguments, then we will check if the total marks scored by this X person is greater than max. So max is initially 0. Let's say the total marks scored by this person is 200. So 0 is greater than 200 is greater than 0, right? If
Yes,
something
ma'am.
is
Yes,
greater
ma'am.
than max, that means we have to update all 3, right? Third max, second max, as well as max. That's what we saw.
Yes,
But
ma'am.
now here the only change is that every time that you update third max or second max or only max, you also have to update the IDs, corresponding IDs. Okay. If third max now contains the value of second max, then third max ID should contain the value of second max ID. Is this clear why this is happening?
Yes,
Because the
ma'am.
ID of the person should correspond with the marks, right?
Yes, ma'am.
Similarly, if second max is containing max, then second max ID should also contain max ID. And max is now containing the actual marks, total marks of this person, X dot total. So max ID is the ID of whatever this X card is. Okay. This part is just, these are all components. Okay, we are not done with this procedure. Another condition is what? See, here also there will be 3 cases. One is X dot total is greater than max. Second is X dot total is less than max but greater than second max. If this happens, then how many variables we need to change? Only third max and second max. We don't need to change max, right?
Yes, ma'am.
So third max is containing second max. Third max ID is now shifted to second max ID. Second max is containing second max is containing X dot total, and second max ID is the card ID of this X card. What is the third condition that can happen? We had 3 conditions. What is the third one?
At least one girl.
No. I'm not talking about criteria. See, one is X dot total is greater than max. One is X dot total is less than max, greater than second max. What is the third one?
Ma'am, X dot total is total mark of that particular student.
And less
Yes.
than second max.
And greater than third max?
Yes.
This one? This is the third
Yes, ma'am.
criteria. So if this happens, then how many variables you change? Only third max. So third max will contain x dot total and third max ID will contain the ID of this expired. Okay. All of this will be only, we will check all of this if this subject proper procedure returns true. We don't yet know what is subject proper. If it returns true, then we will check all of this. Okay. Now see what are the variables of interest here. Max ID max, second max ID second max, third max ID third max. This is all we are working with, right? Now see, now we are going to check what is the subject of our procedure doing. Okay. So card, what are the parameters? Card, M mark, P mark, C mark. That means, what is this meaning?
Maths
Let's
mark,
say,
maths mark, physics mark, chemistry mark.
right. If I have card X, then this is X dot maths, X dot physics, X dot chemistry. Okay. Inside this procedure, what we are doing first, check if card dot maths, that is whatever this X card you have picked, their maths marks is greater than M mark. Wait, M mark, P mark, C mark. I think it is defined somewhere. Let me check. We didn't define this anywhere, right? M mark, P mark, C mark. I think these are the maximum marks in those subjects. Just a second, let me check, confirm this one. No, this is actually not defined anywhere. Okay, no problem. We'll check. So compare each subject's marks with the third highest. Okay, these are the third highest marks. Okay. M mark is the third highest maths marks. P mark is the third highest physics marks. C mark is the third highest chemistry marks. So where did we get this third highest from? From which procedure? Top 3 marks, right? That was returning the third highest. So these are the third highest. Now this is the card I have picked. So I am checking whether the maths mark scored by this card is greater than equal to third highest in maths. Why greater than equal to we are checking? Anyone can tell me? Why this equal sign?
Because it will be third highest.
Because it can be the third highest or it can be greater, right?
Yes,
So
yes,
if it
ma'am.
is greater than third highest, that means that person is a topper in that subject.
Yes, ma'am.
Okay. So for all 3 of his marks, let's say I have picked card X. So I'm checking whether this person's maths marks is greater than equal to the third highest maths marks, or whether his physics marks is greater than equal to third highest physics marks, or whether his chemistry marks is greater than equal to third highest chemistry mark. If any of these are true, then I will return true. Why? What is our second criteria? That the person should have been the topper in at least one subject. That's why it is OR. Okay. So if any of this criteria is fulfilled, it will return true. That means this person is a subject topper in that subject, in at least one subject. Correct?
Yes, ma'am.
Others, is it clear? Any confusion you are having?
No, ma'am.
Okay. Now see, this is a big one actually. This is a big procedure. So up to this is fine. Okay. Also, now tell me one thing. If some person has scored, if for some person, this procedure, this criteria, as well as this criteria, both return true, will that person also be considered as a contender for the top 3 prizes?
No,
Yes,
ma'am.
ma'am. It's
No,
true.
no, ma'am.
Yeah.
Why not?
Because only one person in one subject.
What is the criteria? That they should have at least scored highest in one subject. At least
They
means
should
it can
score
be more than one.
More than
It
one.
should be at least one, but it can be more than one. So that person will also be a contender for the prize. Okay. That's why
Then
we are using OR condition.
okay, okay.
Okay. All right, up to this is fine. Subject topper. Yeah, see, this is the entire procedure for 3 prizes problems. It's a little big procedure, okay. So these are the initializations we did initially. Max, second max, third max as 0, max ID, second max ID, third max ID are -1. Maths 3, physics 3, chemistry 3. These are what? Top 3 marks in math, physics, chemistry. Okay. These initializations we did beforehand. So while pile 1 has more cards, see, after all these initialization, then we start picking the cards. Then we start scanning through the cards, right? So first pick the top card from pile 1. Now go to the subject topper procedure. Subject topper is checking what? Whether that person is a topper in at least any of the subjects, right? At least any one subject. So if that person is a topper in at least one subject, then we will continue with this if statement. We will enter. If he hasn't scored among top 3 in any of the subjects, then will I check any of these conditions, these internal ifs?
No, ma'am.
No, right? Because this is only returning true if the person is a topper in at least one subject. So let's say he is, then I will come to this if. Then I will check his total marks with the max, right? So if his total marks is greater than whatever is in max, max is initially 0. Again, you change all this. So if max is getting replaced, then we have to replace all 3, right? Max, second max, third max. If only second max is getting replaced, then I have to replace just third max, not max, right? For this condition. And if this condition is true, we are only replacing what? Third max. These 3 are clear for you, right? These 3 conditions, how these are working.
Yes, ma'am.
So at the end of the procedure, max, second max, and third max will contain what? Tell me. At the end of this entire procedure.
The toppers from individual subjects.
Individual subjects or overall? See, what am I comparing?
Overall,
X dot total.
Top 3 total marks.
Total, right?
Total. 3 total marks. Sorry, ma'am.
See, that individual subject topper thing is already checked here in this line. Subject topper. Okay. In this procedure, we are already checking whether that person is a topper individually in a subject. If that is true, then only we are checking for
Ma'am,
his
where is
total
the
marks.
definition of this subject topper procedure?
See, that this subject topper
You are
procedure
not
definition is this one.
defining.
Okay.
Hello?
It is not written here, but it is there. Okay. This is the definition. It should be
Okay,
ideally
ma'am.
written here. I think because of space or something, they haven't written it. But this is the definition of the procedure. This procedure checks whether this person is a subject topper in at least one subject. If this is true,
Hello?
only then I will check for the total marks. Yeah.
Hello?
Yes, ask.
Hello, I don't understand what I'm doing, ma'am.
What do you not understand?
Yes, ma'am.
I cannot hear him. What is he saying?
Ma'am, I don't understand what I'm doing.
I am finding the 3 prizes problem. That is, I need to find top 3 contenders who have passed 3 criteria. What are the 3 criteria? First criteria is
Ma'am,
that they should have scored highest total in
ma'am, I
class.
don't understand in this topic.
Okay. So like from the beginning you didn't understand.
Okay.
Okay, I will give you a brief overview. Just let me finish once. Is there any other person who didn't understand from the beginning? Okay.
Ma'am,
So
I joined this session in mid.
okay, I'll give you a brief. You just go through the rest of the session once this is done. Okay, the recording is available. If you have any question after that, you can ask me. Okay, I'll give you a brief after this.
Ma'am,
So others,
quickly revise this, ma'am. We have another session.
yeah, I will. So up this 3 prizes is clear, right? This entire code. Any problem here?
Until then, there is no problem, ma'am.
See, first subject topper is going to check whether the person is a subject topper in at least one subject. If this is true, then only we are going to check for total marks. That is whether he is among the highest total mark holders. the top 3 total mark holders. So the 2 criteria are done. Only one criteria is left, that the top 3 people, at least one should be a boy and at least one should be a girl. This is the last condition that is remaining. Okay. So what if all prize winners are of same gender? Then what we will do, we will exclude the third prize winner and repeat the process. Okay. So let's say I got the top 3 people, the top 3 prize winners, but they're all boys, but I need at least one girl. So I will exclude the last person. That is the person who won the third prize. That third boy I will exclude, and I will repeat the entire process until I get a girl in the third place. That is, I will discard that boy's card. Okay. And I will repeat the same procedure until I get a girl who gets third place. Until that happens, you keep on repeating this. Understood? This is not a good way of solving, but this is the way we are going to do it. So how many times till we get 3
Ma'am,
prize
even
winners?
though the third boy has scored more than
Yes,
that girl.
exactly. It's not fair. I'm not saying it's fair, but our condition is what? That at least one girl should be there in the top 3. Okay. So to fulfill
Okay,
that
ma'am.
condition, you are going to exclude the third person and repeat this until you get one girl. Similarly, if all are girls, you are going to exclude the third girl and repeat the process until you get one boy.
This process is
Okay.
getting much more complicated from now.
Yeah, it is.
Yes,
It is.
ma'am.
It is complicated. I told you in the beginning only. See, up the first 2 conditions comparison is easy. That is finding the total highest and the finding the subject wise toppers. But there is no guarantee that the people that we are going to get from checking these 2 conditions will be all, like there will be one boy and one girl, right? It could be all boys and all girls. So what you will do is every time you get all same gender people, all 3, you're just going to exclude the third person and again repeat the entire procedure. Okay. So what if there are ties? Now there can be
Girl
ties
can be,
also.
ma'am, girl can be last also in the class.
Yeah, anything. See, there it can be that there is only one girl in class. Then you have to go wait
Yes,
for
yes.
that girl, right? So this is not a valid. I'm not saying
Ma'am,
this
if
is a
the third
valid or
place is
fair
a
procedure.
tie, we will give the third prize to both.
No, the tie condition I'm not going to discuss today. Okay, since week 3 you have plenty of time. Third condition, this tie condition will be discussed in next class. I don't want to confuse you further. Okay, let's just, this is enough
When
for
will be the
today.
next class?
Yeah, sorry.
When will be the next class?
It's on Friday.
Okay.
Okay, so just this tie condition is remaining, but other than that, this is how you will do. Okay, so this 3 prizes problem, is it clear for everybody? Just tell me this pseudocode, is it clear?
Yes, ma'am.
Right? No confusion here. So just that tie part is remaining. I will ask you, sir, to discuss that, or whoever is taking that session, I will ask them to discuss this tie part. Okay.
Ma'am, you will take the session on Monday only.
No, it's not like that actually. Next week, I think I will take Friday session, but this week, Friday, someone else will be taking. Okay.
Okay, ma'am. Okay.
All right. So if you don't have any further questions, you can leave. That's it for today. Okay.
Okay, ma'am.
Thank
Thank
you.
you, ma'am.
Yeah.
Thanks for
Thank
supporting
you.
us.
Thank you, ma'am.
Yeah. Thanks for joining.
Thank you, ma'am.
Hello, ma'am.
Yeah.
I don't understand.
Okay, see, I'll just give you a brief on what the problem is. Okay, and now this is a very huge problem which I've discussed. So you just go through the recording once. I'll tell you what the problem is. It's called 3 prizes problem. Okay. There is a
Ma'am, your
problem.
next class when will be happen?
I'm not exactly sure. I think next Friday I will be taking. Yeah, next Monday I don't have class. So next Friday I will be taking.
Okay, thank you.
Yeah, thanks. See, 3 prizes problem is a problem where we want to give 3 different awards to the toppers in a class. Okay. But there are 3 criteria that must be fulfilled. First criteria is that those 3 people that we award the prizes to should be among the total highest mark scorers in class. That is, they should have scored the top 3 highest marks in class. Top 3 highest total marks. Understood? This is the first basic criteria. Second basic criteria is that they should be subject toppers in at least one subject, either maths or physics or chemistry. They can be subject toppers in more than one also, but at least one they should be. Okay. So we are going to find top 3 marks in every subject. If some person has scored among those top 3 marks in even one subject, then that person is a valid candidate to get the award. Okay. If he has scored among top 3 in at least one subject and has scored among the top 3 total highest marks. then that person is a valid candidate. And the last criteria is that among those top 3 people who get the prizes, at least one should be a boy and at least one should be a girl. Okay, now rest of this whole problem is we just learn to find how to get the top 3 marks in every subject, how to get the top 3 total marks. That whole part I've explained. You just go through the recording once. Okay. If you have any questions, you can send it to me.
Okay.
Okay.
Thank you.
Yeah. Okay. Thank you.
Thank you, ma'am. Where I get the recorded lecture, ma'am?
A recorded one is in YouTube. Okay. The IITM BS degree channel, they're under CT playlist. September 24, you can find the recordings.
So, on YouTube, ma'am.
On YouTube, yes.
Thank you, ma'am.
Yeah. Thank you, everyone.
Okay, ma'am. Thank you. Bye.
Yeah. Thanks.